Okay. All right, Sergio. We'll looks like we got a lot of people doing some work in the background, or other people in the room doing work for as well. Um, so today we're going to go over how Ortelius and the CI/CD process fit together, and I'm going to take a look at what we have as far as the CI process, as well as some of the pieces where we kind of insert in, and this is going to tie into some of the blog that Sasha put together. So let me go ahead and share my screen. If I can find that. All right. So one of the things that when we think about the CI/CD process and what we're trying to achieve is the capturing of new components when they're being created. So one of the things that I have here is I brought up the Ortelius user account on the SaaS version. And what we're going to see here is we have like the website, the user guide, and some of these are based off of maintenance, based off of the master branch. So one of the things, the way the triggers that we set up in the Google Cloud build was to look at any branch that came in, and we're going to go ahead and build and record it. Some of them will only do it on a pull request. So we'll only be looking at the main part. So one of the things that if we pick one of these, this is one of the last ones deployed, is this is the container that is going to be for the documentation. So what we can see is we did a hook into our cloud build, and we recorded information about the build. We have the chart that's used to install it, and then we have information about what was produced in the build process. So we have the registry, the digest, the tags, and the Git info. Now, why this is important is if we look at the CI/CD process overall, anytime that there's a build that happens, we want to treat that as a potential version that can go out to production. So there may be, if we go back to our list here, we may have a lot of versions of components that may never make it out to production. You can see in this list here, a bunch of them were never deployed. The last one that was this one, build 985 or deployment 985. So that's one of the things that in the CI/CD process, we want to capture that information about what's being created, where it was stored, and how can we get to it. Because everything we're dealing with here is basically Docker containers, it makes it pretty easy. We're going to be pushing to a registry. We're going to know where that registry was pushed to. We want to grab some information about that. So now when we go down the road, after we do this information gathering, that we're going to be able to then, when we want to, go ahead and do the deployment step. Now in the deployment step, we'll use that information that we've stored at the component level to go ahead and pull out of the registry and push into the cluster, for example. So let's go ahead and take a look at how we actually did that initial capture. And we're working with the docs. So, and Sasha's blog does a really good job explaining the different steps into the cloud build. So I'm not going to go into super detail about what's happening at that level. But I'll point out some of the key points that we have. Um, things that we need to know are going to be like what's going to be the application that we're going to associate this version of the component to. What is the name of the component, like the base name? So in this case, it's called user guide. Some other things, one of the Joe Veda, who actually ended up writing part of Kubernetes, now is working for VM. We showed him what we're doing in one of our old demos a couple years ago. And he said, you know what, your branches, you should treat those as variants. So a variant you can think of as like a feature branch. And within a variant, you can still have versions. So I could have, a new microservice that we're going to be, or let's say a new sign-on that we're going to have to deal with privacy issues. So we may have a new terms of agreement, and that may be the feature branch, be terms of agreement that we want to track as a variant versus what's out there as part of the existing pieces. So variant is optional. And then we have our versions. These are schematic versions. In this case, I've just defined, basically hard-coded the beginning part. The ending part you will see here is I'm doing a little trick with the Git repo where I'm actually going in and counting the number of commits on the branch. And that allows me then have a like a build number, for lack of a better word. Because in Google, if we remember back on the Google Quase, I mean on the Google side, on the cloud build, our build ID is this weird hexadecimal number. It's great for having uniqueness and stuff like that, but it's not practical for the versioning schema. So that's where I do this little trick to go ahead and get the commit count. And then I like to tack on with a prefixing it with like a -G to identify that it's a git commit, the short SHA. And that's where at the end of the day, we end up with our name. You can see here we have the user guide, which is the base part, the maintenance, which is our variant. Then there's our schematic version with the git commit number incrementing, and then the short commit right here as part of that that name. So that gives us some a way to identify very quickly this version of the component. So that's kind of where we're setting up some information. We're going to also...
Weird question for you, Steve.
Yeah, go ahead.
Are the dashes getting mapped to underscores?
Yeah, it's a weird quirk that we started out with the original version of Ortelius when it was called Release Engineer. There's I don't know if you guys remember, there's a world, there's a whole this whole piece of Ortelius called DM scripting. It's a scripting language that we ended up writing, Phil Gibbs ended up writing, and because it's its own language, things like the dash here, when you get into the scripting language, gets interpreted as a minus sign, so it tries to subtract the two words, which throws an error. So we actually have to go through and kind of scrub the names and put them into underscores. The other thing that you'll see is there's no periods as well, because periods actually end up as part of the domain name structure. So global.ortelius.sas. So user IDs, like if you do like first dot last name, we actually convert that to first underscore last name. So there's a couple weird quirks that we've had to deal with that we've been carrying along. When we eventually get to the point where we can rewrite the deployment engine, we can fix those restrictions down the road.
Thanks, Steve. That was cool.
Yeah, it's a weird one that just got carried along, and it's just, unpinning it is a bigger project than I was hoping for it to be. Some of the other things that we are kind of grabbing, are setting up this point. Where is this going to get pushed to? This is just the action that we're going to run to do the deployment. And this allows us to have some flexibility. If we have to do like a Salesforce deployment, we'd be using a different custom action instead of Helm chart. In this case, we want to know what our chart name is. Chart name can also include chart museum, the URL and pieces like that. That's in the documentation. And then which environment that we're going to actually be associating and deploying this to. Other things that we're kind of doing at this level is figuring out the tag name for the Docker push. Again, we're pulling in the commits, and it's basically going to be a mirror of what we have at the version level here. And then finally, where we're going to update, I'm going to actually bring this up in my editor. It'll be easier to go find that one. I can word wrap it so you guys can see it. Work in docs. Okay. So the line I'm looking at here is the DH update comp. And with all these parameters, you can see all the environment variables that we defined earlier. We're just passing those across. And this is where like some of the keywords are coming into play. So when we update the attributes, so everything with the comp adder is we're updating attributes all the way through into the UI and storing them to the database. Certain keywords we pick out and we put on certain places on the detailed dialog. So things like that we have coming down the road for the service catalog, like Slack channel, PagerDuty URL, logs, those types of attributes will map across as part of that process. So this dhcomp update is actually a Python script, and it is separated into two pieces. There's the main driver. I can get up to the top here. Close this here for you. So the main driver is the DH, basically the executable part of it. And then there's the API piece. The API piece has all the, basically the RESTful API calls that we need to do. So if we want to clone, that's a bad example. Like here, assign a component to an application. So basically we pass in some parameters, application, everything in Ortelius is stored based on an integer for the ID for the object. So we pass around a bunch of object IDs. And in this case, we're making a couple RESTful API calls out to the endpoint, doing those associations. So what we've tried to do on this side is really simplify by wrapping all the API calls into something that's a little more meaningful at the Python level. And then the driver, like I said, has a couple different modes, whether we're going to be doing like a deployment, we're going to do approve something, move something. The one we're looking at now is the update comp, which is updating the data about a component. A couple interesting other flags on that. We can actually auto increment the application version, and we can also auto increment the component version. So we could have it work in two modes where we can replace the existing component that was there previously, or we could keep on creating new versions of the components. And then when we create a new version of the component, we can then go ahead and create a new version of the application. Just assigning components to applications. Another one that comes into play is key value pairs. This is where we can actually pull in like a properties file and load those in as attributes to the component version as well. So if you have key value pairs that we want to like config maps, those can come in and be associated to the component version. Now that's a separate step. So on our cloud build, if we wanted to do that, we'd actually have to run the comp update twice. The DH twice. One's with comp up with update comp, the other one with the KV parameter. Some other things: importing, exporting objects, so you can move them between databases. Environment script has to deal with dealing with weird quirks and CI tools that don't understand how to create persist files and data between steps. So that's just one of the things that we had to do to help with persistence. And then just a list of all the parameters that are available. And there's a corresponding markdown for this. Oops. There we go. Oh, where'd it go? I want file list. I got myself in a weird mode. There it is. Doc. So we did, you are able to look at the markdown for both the API level, which is the deploy hub, basically the deploy hub Python module, and then the driver has the markdown as well. Both this whole Python piece gets pushed over to PyPy. So you can download it just doing a pip install of that, and you can then incorporate it into your CI/CD process. Now, one of the things that we're doing at this one in our cloud build is we're actually doing a deployment as well. So we're kind of like wrapping both things at once. So after everything's been updated, we're actually going to deploy to that deployment environment that we defined, which is going to be our AKS cluster. So after everything gets updated, we're going to go ahead and deploy right after that. You could do the two steps. You could do the update comp and then come back and do the deploy. We just kind of did it as convenience to wrapper it all as one as part of that steps. So that's kind of what's happening at the CI level. Like I said, we can break this. If I leave off the deploy env, we would just be updating the components, and possibly if we have auto increment on, we could be incrementing application versions. Let me go ahead and close that, and we'll go back to this guy. So if you look at the application, this one's pretty simple. If you look at their last deployment, that was for the website. This one, I got something going on crazy. Shouldn't look like that. I have a parameter set wrong, but we'll look at the docs that we're just working with. 85. So you can see that we have our one component assigned to this version of the document. Of the application version. And if you look at our packages, same view as part of that process. And then we have our cluster that we deployed to, our deployment log. If we actually look at that, we can see that it used the Helm chart, went out to Azure. This is where it's logging into Azure, setting the context for us to connect kubectl to it. Then we get into our Helm deployment, and it's been upgraded as part of that process. So that's kind of what's happening on the deployment side. Now, in a traditional CI process, we would want to do, like on the CI level, we probably want to do a check-in, build it, and deploy it to the dev environment. So that's kind of like what we have going on with our deployment environment. As if in the regular pipeline you think about we got to go to QA, we would then at the application level, I don't have it set up because we're doing QA is slightly different, but I would go ahead and pick which environment I'd want to go to. So I would have to have a QA environment or prod environment listed here that I would go ahead and deploy that version of the application to that environment. And because we have everything basically tied at the component level, all the metadata that we need to retrieve the image out of the Docker registry, we can go do this and repeat. It's basically rinse and repeat at any stage of the pipeline, whether we have something going on at dev or at prod. We're going to do the same process. We're going to pass in different data. We're going to pass in key value pairs around the production environment versus key value pairs for the development environment, but we'll be able to move that and repeat and pass in the data down the pipeline. Any questions on that? Okay, we're going to jump over to another way to do this because a lot of people still use Jenkins for the pipeline, and we actually have a Jenkins library, a Groovy library. It's also called Deploy Hub, is the Groovy library, and there's a it lives out in our, I think our Ortelius repo. I can't remember off the top of my head, but basically we can get into fancier stuff on the Jenkins side. So again, we go through and define, a bunch of variables just to make things easier. And then we get into being able to create a new component version. So I tried to mirror these between the Python library and the Groovy library. There's some divergence between the two just because of the requirements that we had initially for the Jenkins side. But basically, this will go ahead and create us a new component version if we need one, and then return the ID that we're going to use. Here we're going to update the attributes, basically the chart and the chart namespace, those type of things. Those attributes are coming across through just basically a dictionary in the Groovy side. And we'll go ahead and pass that array of key value pairs over to the update component adders. So it's the same concept. Underneath the covers, the Groovy library is doing basically the same RESTful API calls. But we do have a little more flexibility from this point. I actually have one of our customers is doing a deployment. They go and check to see if the deployment is successful. If it's not, then they actually automatically do a rollback of the deployment. So they deploy out to an environment, they run their test cases through their Jenkins pipeline. If they don't like it, then they actually go and automatically roll back to the previous version that they had out there. So there's a lot more flexibility in the Groovy library side, and there's a full documentation. Let me see which repo it's at. I think it's at the Ortelius one. Oh, I remember. It's in a weird place. It's in... It's off of this weird Jenkins. I'll find you guys find everybody where it is. I can't remember. It is... Let me see if I can find out my repos here. It's off a weird one because it's off of the Jenkins site where the repo is. So it's not under our organization. I'll find it and put it out in the Discord channel. But there's full Groovy docs that we've created for it and everything that happens around that. And that will I'd love to get rid of the GrooveView library and just do everything off of the Python library. But there's some functionality that's missing in the Python that we need to deal with. So one of the things that we've been kind of moving to, this is dealing with Salesforce. And here we can see that we're basically, I just stubbed it out, but basically we're calling update the Python library from just a command line call in the Jenkins script, in the Jenkins file. So that's the other way that I'm looking at. But when you get into this, there's not as much flexibility to make those decisions like the automatic rollback and pieces like that. So I'd love to get rid of the GrooveView library, but I have a feeling it's going to be around for a while. But overall, our goal is to be able to gather information from the CI process, store it at the component level, make our associations that are going to be pulled together as part of an application version, and then go ahead and be able to deploy it right then or be able to deploy it down the road. Now, one of the other modes that the Python library kind of works in is to be able to record a deployment. And this is where most people start with, is they'll have some sort of process, like they'll have Helm running, or like in the Salesforce case, they have Jenkins calling Salesforce through the Salesforce plugin. But we want to record what those deployments are doing. So there's another mode where we can pass in a list of components that were deployed to an environment. And we can, the Python library will then go ahead and create an application version around that, those components. And it's basically, it's given basically a JSON file saying, here's the environment name, here's the application name, or and this is the list of components that we're going to record for this this deployment that this other tool did for us. One of the other things I'm working on, and hopefully going to wrap up this week, is being able to take the output of a Kubernetes deployment description. So this is data from dumping basically the deployment YAML from a running cluster. So we're basically like reverse engineering the cluster to figure out what is in there. Because one of the things that, because we're storing it, we can actually work our way backwards. So in this case, this image is the image that is actually being run by the Kubernetes cluster. Now, because we have that image, and on our side, let me pick one of these. We have the basically we know the image because we can concatenate together the registry and the tag. We can actually go backwards and figure out what is the actual component version that is running in the cluster. So that is one way that we are going to be able to pull together what is an application version running in a cluster. Now, most people have been kind of grouping together their application versions in a namespace. So that gives us a little more context to put around what is an application at that level. One of the things that we ran into is handling multiple container tags that point to the same digest. So this customer is renaming or retagging as they go from stage to stage. They'll say QA latest would be like one of the tags that they put on this digest, and then they'll do prod latest. That way, when they get to their production deployment, they're always pulling prod latest tag as part of that process. Because of that, we actually have to work backwards from the digest because the tags won't necessarily correspond. So because the digest is available there, and we can from the, where'd it go? Come on, editor, wake up. There it is. So even though we don't have the digest at this level, we can actually do two things. You can actually run a kubectl command, I'm sorry, a Docker command to go query based on this tag what the digest is. The other way that we're thinking about doing it is at the label level. We're actually going to label the digest into the deployment. Just for speed's sake and convenience, we'll put it at that level so we can retrieve from there. So we'll be able to work our way backwards from either the image tag or the digest and get us to the component. Now, what this allows us to do is record what's happening at the cluster level. So if we get 2 microservices that get deployed in a Helm chart, and they have Jenkins doing that deployment, interacting with Helm. After that Helm deployment's been completed, we're going to go ahead and record through the Python library that the cluster has been updated, and this is the new version of the application that was created with these 2 new versions of the components. Now remember, those components are already created back at the CI level. So we're just making the association of the new component versions to the new application version running in that environment. You know, one of the goals that we have is really just tracking these relationships as they evolve from inception to final deployment as part of the process. So any questions? That was the main stuff that I wanted to go over. Does that kind of make sense how we're kind of fitting together and hooking into the CI/CD process? Now, Sasha's blog goes into the details of what's happening at the cloud build level. So he'll answer all those questions for you on that.
I have 2 questions.
Mm-hmm.
Yeah, maybe more general.
Yeah.
I'm wondering, because you show us the list of components, I think, on the website of the Git deploy hub.
Mm-hmm.
And I'm wondering about, can I consider this as a history of commits?
You can. You can consider it, well, only if the commit triggered a successful build.
Okay.
So if you have a commit that fails the build, there's like a build problem, then it would never make it over to Ortelius or Deploy Hub.
But it will be visible as not succeed line, let's say.
No, because it would be like, let's say Jenkins is doing the build and it failed the compile. The next step would be to go ahead and tell Ortelius that it was successful, that a new component was created in the Docker registry, and because it never got to the Docker registry, we'd never record it.
Okay. So maybe second question is that because the idea is that different customers will use different versions of the components, right?
Mm-hmm.
So I'm wondering, is it possible to archive not used lines or components just to save space or something like that?
Yeah, that's one of the things that is that we need to do as a way to make the UI load faster is when you get a lot of these component versions and application versions that never made it out of the initial CI build, that they do get in the way. So an archiving feature is something that we need to look at. And if you could open an issue for that, that'd be great. Because
I don't know.
Huh?
Yeah, I don't know how to describe this. That idea just came to my mind.
Well,
Just
just
right
put
now, so.
archive components. That's all we need.
Okay, great. So I put the issue.
I can fill in the details. I just forget to. I have so much going on. I forget sometimes.
Okay, great. Okay, I'll put the issue. Thanks. That's all from my side.
Yeah. Anybody have any other questions?
Hi, Steve.
Hey,
So like how, hi, sir. So like how are we creating the dependency graph? Question one. And the second question was how we are checking the health status of a component. Like suppose a component goes down. So how are we able to detect that?
Right. So the initial creation, so one of the things in components is, and applications, we like to start with what's called a base version. The base version, we basically kind of strip off all the variant and the like the version number, and that becomes our base version that we start with. From there on out, we then create version 1 of the component, or so components and applications, and pretty much everything works the same way for versioning in Ortelius. So we'll go ahead and create the new version. So we have our base version, version 1. So base version you can think of as base 0, version 0, and then version 1 is going to be our component that we just created. And then if we have another update that comes along, we'll go ahead and look for the parent of, there's a whole parenting tree. So you know through the version tree who your parent is, and then also you know who your base version is as well. We keep those relationships as part of the database data. So when we create version 2 of a component, its parent will be version 1, and then version 1's parent will be version 0, and both of them will have a base version of version 0. So it allows us to navigate the version tree very easily. It's based on name. If you have the right, if you're creating a component in the same domain, you know, like I had Ortelius.sas, and then the same base name, then it's going to be considered the same component that we need to update as part of that process. So that's kind of, and the same logic works with applications as part of that process. Does that make sense on the versioning?
So basically, based on the environment variables that you're mentioning, the domain and all this name in the CI/CD pipeline for that component, we use that data and basically based on the domain structure that we have separated by dots, we use that and create the dependency graph.
Exactly. Now there is a scenario, and I can't remember how which part enables it, but let's say you do a deployment into QA, and that you just deployed a single microservice. I'm sorry, it's when you create a new microservice. So if you create a new microservice and you have 5 applications that are consuming it, you would then go ahead and find where the previous version of that component was used in which application. So we know there's these 5 different applications that were consuming the -1 of our component version, and then we'll go ahead and create new component versions for all 5 applications consuming the new component that we just created. So there's some tricks that we do behind the scenes, but in order to do that, we need to have a starting point. And that's the hard part, is getting the starting point. And that's why I've been looking at basically reverse engineering a cluster to give us based on a namespace to give us a starting point.
Okay. And regarding the health status, how would you do that?
So Ortelius and DeployHub don't do anything on transaction monitoring or health status or anything like that. So in our proposal for the service catalog, one of the things that we're going to add is links to monitoring tools. So if you wanted to, for example, for this microservice, we know that the Datadog URL for this service is X. And that's some of the service catalog data that we want to embed at the component level. So if somebody has a problem with a component, they want to go look at the Datadog output or the log stack driver logs, that they have an easy way to get to Prometheus logs. That information is where we want to associate it at the component level as part of that service catalog information. And that's where it gets tricky, because if you look at other tools that are out there, they're focused just on, what is the health of production? Where are the logs for production? But developers, when they're doing work, QA says something's broken, the first thing they want to do is go look at the logs. And if they know where the QA logs are for this cluster, for this microservice, and they could just get to it really quick, they're going to be much happier. And that's where, it's like this end-to-end relationship that we have to deal with when we're talking about this version of this component lives in these N environments. These N environments each can have N clusters. And because of that, we're going to have N logs for each microservice. So it kind of just cascades out as we look at those relationships.
Got it. So regarding that, so like my blog was regarding that part, like microservice visualization, basically observability. So I came across that there. So basically, different systems are there. Like, so basically, the three kind of data are log, metrics, and traces. So traces basically the transactions. Mm-hmm. And most of the systems have different screens, and there doesn't exist any correlation. So the manual labor goes so much to like, suppose if some problem strikes us down, we have to like manually do all those things and correlate on our own. So like this is the moving trend that towards a generic solution where we can get all these three data together and correlation between them. Yeah. So like if the service goes down, we can get the logs. We can get the logs, traces, as well as the metrics of the system if we want.
Exactly.
And also, like if you're mentioning the links of different tools, like there's a standard being developed currently, like OpenTelemetry.
Right.
So basically currently all this we need basically standardization is needed. We are having lots of tools that they are doing this thing, but there is no standardization in the format of the data. So basically, OpenTelemetry project is around that, and if we can utilize that data, we can maybe in the future we can show that directly instead of links. We can also show that metrics in our Ortelius.
Yeah, exactly. And I'd love to bring in that that data directly into Ortelius. But like you said, that because there's no standard, we spend a lot of time chasing vendors to get their data. Now, and that's why right now the easy out is to give a link to the other tool, just so we can kind of aggregate together all the links as a one-stop shopping dashboard for a service for people. So other things that are at like the service catalog level are going to be what's the developer Slack channel, who's the owner, what's the email address and phone number of the owner for this microservice, what's the PagerDuty service sheet look like. Those types of things are important as well. And then, like you said, overall, if we could start bringing in some base, a green red for a service at an environment level, that would be huge. Now, there's a whole nother thing around policies as well. How is this service conforming to the policies? Now, there's policies come in many different flavors. You can have SLA, SLO policies. Am I, maintaining my uptime type of thing? Or do I have too much lag time? Is it too slow? Those types of policies. But then you have security policies. You have business policies that we need to look at as well, and those rules that need to go around it. So there's a lot of data that we can associate to components, version of a component, and roll those up at the application layer. Now, one of the things that as part of the service catalog that we're looking at doing is it's kind of along the policy-ish side, is when we have a Docker container, let's say it's a Python container. Python's going to have all of its modules that were installed into the container. Now we can run a security scan against that container, and we can grab there's two things that we need to grab. One is, what are all the licenses for all the each module, because we need to know if we have some module that's a license that the attorneys don't like. And then the second one, what are the CVEs? What are the vulnerabilities that are out there? So those we'll need to roll up at the container level, and that would be, here are all the licenses and all the CVEs for this component version. And then from there, because of our relationships, we can roll that up to the application version. And I get this all the time. It was one of the first things that we ran into with trying to be part of the CDF is, give us a list of all your licenses that you use. Everybody asks that. So if we can go through and roll these things up to the application layer, I can just click and say print, and I'm done within a couple seconds of providing somebody what my license consumption is. So that's kind of where we're headed with the service catalog data. And I'd love to be able to bring in telemetry and health status, those types of things as well. So definitely keep your a pulse on what's happening on the open telemetry side for us.
And most of the CNCF projects are also like contributing to that. So like we can connect with them and see like how they're proceeding. That also help us.
Now, some of the things that we can look at to start with, just start with like maybe a Prometheus, open telemetry with a Prometheus, or if they have some way that we can initially integrate and wait for other tools to be brought into the open telemetry, that could be a way, because we have because we're coming from the development side, so we know what the developers want their application version to look like when it runs and when they get it to a cluster. Now we have to take the other side and make sure that it's matched up, that we don't have stray transactions, that somebody has a bad route. So we want to be able to marry what the developers are wanting and what the operation side is giving them, to make sure that both sides are meshing together, so we have a good view of what's happening for the application. Because one of the things that we're hearing a lot now is it works in my cluster scenario, and part of it is the people, when they came to Kubernetes, they didn't take the opportunity to change, to make their development practices and their operation practices better. Basically what they ended up doing was they're treating a Kubernetes cluster as a server, and everybody gets their own server, just like we used to have server farms for every application team. Now we're having cluster farms of every single application team getting their own cluster. But there's no need for that. If you look at the way Kubernetes is designed, it can scale to 500 nodes. 5,000 nodes that you can scale to. So there's plenty of room for multiple application teams to live in the same cluster and be separated by smartly, I should say, put the word smartly around it, smartly separate applications based on namespace. and when I talk about that, you want to have reusable pieces in your domain-driven design. Those should be in a namespace that can be shared by other applications as part of the process. So you don't want to have copied the same microservice into 15 namespaces, and it's the same container in all 15 namespaces just because they don't want to figure out namespace security and RBAC. You want to have those reusable pieces in one namespace, and then you set up the routing and the security so they can be shared across the 15 other namespaces as part of that process. We're getting, there's several bad habits that we're carrying forward from our past that it's going to be a challenge to get people to change. But I think some of the things that will help will be something like Istio, service mesh routing will help. That's just me going off on a tangent.
Yeah, so there's been some pretty heavy technical stuff kind of gone through. If anybody out there wants to, have a further discussion on it, I'm totally open to chatting as well. Because I know there's some of you out there who are sort of new to this space, so don't feel if it was overwhelming today that you can't reach out and say, okay, I didn't understand this part. It's totally okay. Because we are going to start coding. We got next week is Steve's going to start pushing issues out there. So it'll be, and I think that we have everything set up. We still have to, the cloud build stuff that Sasha documented, we still have to apply that to building our Ortelius container. Is that correct?
No, it's all done.
All done. So, hey,
so
ladies and gentlemen, we are ready.
So on that front, we have, I believe Zach, I saw was picking up some of the microservices that we did back in October to add in the Helm part and the cloud build part. So there's some of those microservices that we're adding in that will need the cloud build and those pieces added to it in Helm charts. But that's just part of the new development that we have going forward here. So, everything is all pretty much in sync. The Azure cluster's up there. The one thing I have to do is get some data for people to work with, and that's on my list this week to get out. So I'm just going to export my development database for people to have some data to work with. It contains everybody's password that you guys signed up with.
Don't even say that on it. Don't even go there.
See, I woke everybody up.
Yeah.
No, just kidding. Everybody's like, oh no. All right. Well,
and now we have Natch and Sasha on the call. Natch, are you okay with your blog? Do you need any additional help? I know Sasha had stepped up to say he'd help you out.
It's like the pin, but it's open
Totally
on the
help you,
side.
Natch.
That's quite nice as well.
Yeah, I'll
But
reach out to you,
also,
Sacha.
what's nice about your other
stuck
one that you
with
showed
anything.
first is
Thank
that
you.
turn
You want a
for
blog?
animation,
Is it basically to
turn
write a
always
blog
turn
on
the
that
side, it
one
could
file,
become
the
an
cloud
eye.
build file? Is that the idea?
It could
No.
become
I'm working on
some all
the
kinds of things if you turn it on the
SaaS
side.
version of Ortelius.
Sorry?
Okay, cool.
so anybody have another topic that they'd like to go over in like a couple weeks? I don't mind doing these at all.